In this lesson, we're going to introduce the idea of a linear equation. We're going to talk about what the standard form of a linear equation looks like. We're going to talk about what the slope-intercept form of a linear equation looks like and show you that standard form can be manipulated into slope-intercept form and slope-intercept form can be manipulated into standard form. So standard form, just a kind of a quick idea of what we got going on here. The A, B, and the C are capitalized because the A, B, and the C, when it's considered standard form, are going to be integers. All right, so ax plus by equals c. X's and y's on one side. You have whole numbers, and you don't have fractions and you don't have decimals. The other thing that it takes to really be considered a standard form is that a is positive. So you're going to have to manipulate something in order to make your a positive, or it just starts like that. Then you can always take this form and turn it into this form, and we'll do that in a little bit. So the pieces on here, this is very much, slope-intercept form is wonderful if you're going to try and graph it. You can try and graph it by finding x-intercepts and y-intercepts from this form, but this is pretty common to be able to take this and manipulate it into this and go ahead and graph. So the m out of this represents your slope, also known as your rate of change, also known as your change in your y's, change in your x's, and on our graph we'll probably call it rise over run. The b value is going to represent your y-intercept. So it is where our line crosses the y-axis, which makes it a coordinate. And so our x value is always 0 when we cross the y-axis, and our b value is just going to be right from the equation. So this is where we're going to be on the y-axis. So we're going to go ahead and graph something. So for our first equation, we're going to graph 2x minus 3y equals negative 6. So in order to graph that, again, we could find x-intercepts and y-intercepts, but far more common is we're going to manipulate it and make it look like this. And then we're going to graph it by plotting the y-intercept and then just applying our slope over and over and over again. So to get the y by itself, we're going to rearrange. So first thing is, I'm going to subtract the 2x over. All right, that's going to get us a negative 3y equals. Now I could just put a negative 6 and then minus 2x. And it's not wrong, I like to keep it in that consistent where it's my mx, my slope, and my variable are first, so I just kind of always know where they're at. So I'll put this like that. All right, so the y is not quite by itself. I have to get rid of a negative 3 that's multiplied to the y, so I'm going to divide each piece by negative 3. So when I do that, I have a y equals, I have a negative divided by a negative. I can't simplify my fraction, so it's just a 2/3 x. I have a negative divided by a negative, so that turns out to be 2. So from here, my slope and my y-intercept are right there in my equation. So my slope is 2/3 because I kept it in that same format, so it's 2/3. So since it's a positive slope, my graph is going to be going up, and then I have a y-intercept at 2. So I have a y-intercept at the coordinate 0, 2. So we'll just kind of draw a rough sketch here. So we'll plot our point. We're going to start with our y-intercept. So our y-intercept is 0, 2. And then we apply our pattern. Now this is our rise over our run, or our change in our y's and our change on our x's. So we're going to go up 2 over 3. And since it's linear, it contains that, it remains that pattern of up 2 over 3, up 2 over 3. So 1, 2, 1, 2, 3. And then it would go again up 2 over 3. But I can also go backwards of down 2 and back 3, and then down 2, back 3. And if I connect those dots, oops, then we have our line. Now those lines, just so you're aware that if you were to take this coordinate, and that coordinate is 3, 1, 2, 3, 4, and the whole idea of this line is this line are all the coordinates that satisfy the original equation, which basically means if I take that 3 and that 4 and I plug it in, so if I plug it in, I'd have a 2 times 3 and then minus 3 times 4, and that's going to supposed to equal negative 6. Squeeze it in. So I have a 6 out of that. This makes a minus 12. That's supposed to equal a negative 6, and it does. So if I take every single coordinate on the line, it would satisfy the equation, so it all would add up to negative 6. That's the whole point of the line. Those are all the solutions to that equation, all the x's and y's that go together. All right, so we're going to do a couple more, and we're going to do a couple special cases. So if we graph y equals 5, so very different. It's a linear equation in the terms of it's a straight line. It's actually called a constant. So if you graph this, y has to remain at 5. There is no relationship between the x's and the y's. Y just has to stay at 5. So if I were to graph that, my y value has to remain at 5, which basically means that it would be a whole bunch of coordinates on a horizontal plane. And so y equals 5 looks like that. And then our next situation is if I wanted to graph another special case, is if we wanted to graph x equals 5. It's the same idea, that it's different than this. There are relationships between the x's and y's. As x changes, so does the y. But here on these, it doesn't have any relationship with them. So x just remains at 5. So if you're going to start graphing and plotting points where x is 5, you're going to graph it and it's going to stay on a vertical axis. So every time you just have an x equals something, it's a vertical line. Every time you have a y equals something, it's a horizontal line. And every time you have an x and a y mixed, you're going to have an angle of some kind. This one was a positive slope, but you could also have a negative slope. All right, we're going to do one last problem. And this time, get rid of this, we are going to, from this graph, we're going to create the equation for that line. All right, so our directions are going to be write the linear equation of the graph in standard form. All right, so we need to pull some pieces off of this. So first thing that I'm going to notice is I have a y-intercept. So there's our y-intercept. Our y-intercept is 0, negative 1. Okay, then I also have point to point to point, and so I should have a slope that applies to it. So if I go from any point to any point, I can count and figure out what my slope is. So if I count that, I'm going down 3 and I'm running to the right 4. So let's say I go back here and I go the other direction. For whatever reason, I decide I'm going to go this direction. Doesn't matter. I'm going up 3, but I'm going back 4. So on that slope, I have an up 3, my rise, and my run is back 4. On this one, I have an up or a down 3, right 4. Well, regardless, I'm getting the same negative 3/4, and I have a y-intercept of negative 1. So let me pull that information over. And so we have our slope equals negative 3/4. Our b value was, our y-intercept was 0, negative 1. And if we remember what the equation is supposed to look like, at least in slope-intercept form, we can pull it right into this. I can just substitute in what I know. I know the slope and I know the y-intercept right from the graph. So I have y equals negative 3/4 x, and then the b value is the actual value in the y-intercept, so negative 1. Now that's not standard form though. If it said slope-intercept form, we'd be done. So standard form is we're not supposed to have any fractions, and I got to keep the x value positive. So first thing I'm going to do is I'm going to clear out fractions. Well, that's the only thing that has a fraction, so to clear out fractions, I'm going to multiply a 4, a common denominator, to everything. So it's just like in a previous problem, we divided everything by a value. Well, we can reverse that and multiply everything by a value. So if I distribute this in, I'll get a 4y. And then when I distribute it to this, that 4 cancels that 4, cancels your fraction, and just leaves you with the numerator. And then I'll distribute it over to this, so that'll be a minus 4. Okay, so last thing is we got rid of our fraction. Standard form is our a value, our x value needs to be positive. Well, if that were positive, that would mean that I would pull the y to it and anything, the c value, away from it. But it is negative, so I'm going to shift this piece over to make the x positive. So to do that, I'm going to add 3x. And so that leaves me with 3x plus 4y equals negative 4. And that is my my linear equation in standard form. Now, if I'm not quite sure, I'm like, I think that's the answer, I can go back to my graph for a second. And from my graph, I'm going to take one coordinate other than the y-intercept. So let's say we take that. It doesn't matter, anything on there. So if I take that one coordinate of 1, 2, 3, 4, so negative 4, positive 2. I'm going to pull that from our equation, or from our graph. And I'm going to plug it into our equation and see if it actually is a solution to the equation. So I'm going to check by taking negative 4, 2, plug it in and see if it adds up to negative 4 like it's supposed to. So 3 times negative 4 plus 4 times 2 is supposed to equal negative 4. That makes negative 12. That makes 8. And does that add up to negative 4? Yes. So probably didn't get lucky on that. I could get lucky if I got the y-intercept, because I could get the y-intercept right but the slope wrong and it wouldn't work. But that means I have to get the slope in, the y-intercept and the slope correct, and I had to manipulate it out of the slope-intercept form. So that is definitely my standard form. All right, and this was linear equation and introduction.